In this video, we are going to look at Coulombs law. We know that two like charges repel each other and unlike charges attract each other. So, for example, I got a positive charge here, I got another positive charge here. There will be a force of repulsion between them. Repulsion means that suppose this charge is known as Q1, the charge is known as Q2. Repulsion means that Q2 will be pushed away by Q1, so Q2 will experience a force in this direction, and likewise Q1 will be repelled by Q2, and which means that Q1 will be pushed away by Q2, and it means that it will experience a force in this direction. Likewise, if you got a positive charge here and you got a negative charge here, then there will be a force of attraction between them, which means that both the charges will attract each other. So this Q1 here will be attracted by Q2, which means Q1 will experience a force in that direction, and likewise Q2 will be attracted towards Q1, so Q2 will experience a force in this direction. Now Coulomb law gives us the magnitude or the value of this force of repulsion and attraction. So let me write here. Coulombs law gives us the value of this force of attraction or repulsion, right? So Coulombs law is like this, that if you got, let me again draw it, show my charges here. So this is my Q1, this is my Q2, and these two charges are separated by a distance of d. Then the force of attraction or repulsion between them, force of attraction or repulsion between them is called F, and it is given by K times Q1 Q2 divided by d square, where K is Coulomb's constant and its value is 9 times 10 to the power 9. In some books, K is represented as, it is also equals to 1 over 4 pi epsilon 0. Whether use this representation or K, the value is same, 9 times 10 to the power 9. And Q1, Q2 are the two charges in coulombs. This is the unit, and D has to be, D is distance between them in meters. So we have to be careful to use our units correctly. So let's look at a few examples. So suppose this is my example number 1. Suppose I got a 3 millicoulomb charge here. Let me call it Q1, and other one is minus 4 microcoulomb charge, which is equals to Q2. I call Q2, and the distance between Q1 and Q2 is 2 meters. I can find the force between them. So first thing I need to see is that these two are opposite charges. This is positive charge 3 millicoulomb, and that minus 4 microcoulomb is negative charge. So there will be force of attraction between them, which means both of them will be pulled towards each other, and this force will be same, which means that this F here and that F here will be same. Both of them will experience same force, but it will be towards each other, and this value of this force we can calculate. So we know the formula is K Q1 Q2 over d square. Now K is equals to 9 times 10 to the power 9. Q1 is equals to 3 millicoulomb, Q2 is equals to 4 microcoulomb. Here we need to keep in mind that we are just looking at the magnitude of the charge. The sign of the charge will only determine whether it's attraction or repulsion. In the Coulombs formula, we need to just put the magnitude of the charge. So Q1 is 3 millicoulombs and Q2 is 4 microcoulombs. 3 millicoulombs has to be written like this, as I discussed above. That charge has to be in the unit of coulombs, and 4 microcoulombs will be 4 times 10 to the power minus 6 coulomb, and D here is equals to 2 meter. Plug in these values in the calculator, we get 9 times 10 to the power 9, that's my K. Q1 is 3 times 10 to the power minus 3. Q2 is 4 to the power 4 times 10 to the minus 6 divided by D square, which is 2 square, and that will give us a force of 27 Newton. So all it means is that Q1 here will experience a force of 27 Newton towards the right, and Q2 will experience a force of 27 Newton towards the left. Let's look at another example. In second example, I'm just going to change the sign of the charge, so it's almost same question. So I have 3 millicoulomb, and instead of negative 4 microcoulomb, I got 4 microcoulomb here, only 4 microcoulomb. So the values are all same. So if you plug in the values in the formula, we'll get the same value of 27 Newton. But the difference this time is that both of these are positive charges, which means that they will repel each other, which means that Q1 will push the Q2 away. So that's the 27 Newton will be experienced by Q2 in this direction, and likewise Q1 will be pushed away by Q2, which means that Q1 will experience a force of 27 Newton towards the left. Okay, let's look at one more example, example number 3 here. So suppose it is like this, that let me draw it here. This is my, let me call it Q1, this is 6 millicoulomb, and then I got Q2 here. Let me draw it properly. This is my Q2, and which is plus 2 microcoulomb, and then I got Q3, which is 6 millicoulomb. The distance from Q1 to Q2 is 3 meters, and this distance from Q2 to Q3 is 1 meter. And what we are required to find? We are required to find, let me write what we are required to find. Find the net force on Q2, which is 2 millicoulomb. Okay, so this is my Q2 here. I mean, I can just write here, and this is 2 millicoulomb. So we can first consider Q1 and Q2. So Q1 and Q2 both are positively charged, which means there will be repulsion between them, which means that Q2 will be pushed away by Q1. And this is the force that pushed away means Q2 will experience a force towards the right because of Q1. So let me call that F1. We can calculate the value of this F1. So F1 is equals to force on 2. Let me just use the symbol force on Q2 because of Q1. We already know the formula, so just K times Q1 times Q2 K times Q1 K Q1 Q2 divided by D square, and that gives me a value of I can just calculate it. I will get 12,000 Newton. So that is my force. F1 is 12,000 Newton towards the right. Let me again explain. Let me again state what F1 is. F1 is the force on Q2 because of Q1. Q1 is pushing Q2 away, so it will be in the right hand direction. Now let's consider the charges Q2 and Q3. Charge Q2 and Q3 again are both of them are positive charges, which means that there will be force of repulsion, which means that Q2 will be pushed away by Q3, which means that this force will be F2 here and it will be towards the left, and we can calculate that. So let me write what is F2 is force on Q2 because of Q3, and again we know all the values, so just plug in the formula. K times Q1 times Q3, I mean the first charge and second charge, divided by d square, and that gives us a value of 108,000 Newton. So going back to my diagram here, I can see that the force here is 108,000 Newton. So now we got the force. The charge Q2 is experiencing two forces which are in opposite direction. So we can see that net force is equals to 108,000 minus 12,000, which gives you 96,000 Newton. And here we need to state the direction as well. We can say that this is towards the left in above diagram. Just need to keep in mind that force is a vector, and whenever we need to add two forces, we need to do vector addition. So that is basically, and that means that if they are in opposite direction, like here in F1 and F2, then they will cancel out. And final example that we are going to look at is like this. Let's say I have this configuration here. I have a charge of 2 millicoulomb at the origin, and the coordinates of this point are 6, 0, and I have a charge of 9 microcoulomb here, and coordinates of this point are 0, 3, and I have a charge of 6 microcoulomb here. And what we are required to find the net force on Q, let's call it Q2. So this is my Q2, let's call it this is my Q1, and that's my Q3. So we have to find net force on this 2 millicoulomb charge. So again, what we'll do, we'll have to find individual forces, and then we will need to add them together. So let us first consider Q1 and Q2. Q1 is 6 microcoulomb here, and Q2 is 2 microcoulomb here. Both are positively charges, which means that there will be force of repulsion between them, which means that Q1 will push the 2 millicoulomb Q2 away from it. So Q2 will be, this is the force that Q2, my 2 millicoulomb charge, will be experiencing because of Q1. Let's call it F1, and we can calculate this. F1 is force on Q2 because of Q1. So that is, again, we already know the formula, just plug in the values there. K Q1, that's my first charge, that's my second charge, divided by d square is 3 square. Let me write it properly. That's 3 square, and that will give a value of 12 Newton. So this force F1 is equals to 12 Newton. Likewise, we can find F2. Now we can call it F2 or F3, it doesn't matter. So now we are considering Q2 and Q3. We see that Q2 is positive and Q3 is negative charges, so there will be force of attraction between them, which means that this Q2 charge here will be pulled towards the Q3. So this is my 2 milli Coulomb charge, and the new force because of Q3 will be in this direction, because it will be pulled toward Q2 will be pulled towards the Q3. So Q3 here, and this, let me call it F3. I can find that instead of F2, I'm calling it F3. And what is this? This is force on Q2 because of Q3. And this is, again, we just use the Coulombs law, K times the first charge. And just remember, we are taking only the magnitude of the charge, times 2 times 10 to the power minus 3 divided by 6 square, and that gives me a value of 4.5 Newton. So this is F3 is 4.5 Newton. So the situation is clear now. My 2 microcoulomb charge is being acted upon by 2 forces. 2 forces are acting on it, so we need to do a vector addition. Vector addition is simple. What we do is we draw them in a chain, just like we have done in previous chapters. So I'll draw the first force. This is 4.5 Newton. Then I draw another force which is 12 Newton, and this is my net force F. Simple, and I'll need to find this angle as well. So F is equals to, just using our Pythagoras steps, familiar steps, we already know about this now, and that gives you 12.82 Newton. And the theta is equals to tan inverse. Theta is equals to tan inverse 12 over 4.5. I'll just need to use calculator for that. Tan inverse 12 divided by, just a minute, 12 divided by 4.5, that theta is equals to 69.44 degree. So I will say net force F is equals to 12.82 Newton, and the direction is 69.44 degree clockwise from positive x axis. This is my x axis basically.